This is the brief on the basics of gravitation from Saraswati Vivimunder. We're diving into tutor Niranjan Sarvade's notes, which strip away the dense math to make physics genuinely fun.
Let's talk about gravity. You know, the cosmic glue that holds literally everything together.
Think about it. From a simple falling ball to entire galaxies, it's all ruled by one single force.
And that simple idea? It controls everything from our ocean tides to huge clusters of galaxies.
So, how did we figure out the rules for this cosmic dance? Well, it all started by looking at the planets.
It took centuries, but our view slowly shifted from Earth-centered to Sun-centered, thanks to these brilliant minds.
In Kepler's work, it totally shattered the idea that planets move in perfect circles.
Turns out, a planet's distance from the Sun actually changes all the time during its orbit.
We call these points perihelion when it's closest and aphelion when it's furthest away.
Okay, so his next law gets into how a planet's speed changes as it orbits.
And what's really cool is what this means for how fast the planet is actually moving.
Basically, planets speed way up when they get close to the sun, and then slow right down.
And for his grand finale, Kepler found a mathematical link between an orbit's size and how long it takes.
The takeaway? The farther out a planet is, the longer its year is going to be. Simple as that.
So Kepler explained how the planets move, but it was Isaac Newton who figured out why.
With this one single law, he connected a falling apple right here on Earth to the moon's orbit.
And that tiny number? That's big G, the universal constant that makes the whole equation work.
Okay, so let's bring this giant cosmic force right back down to Earth for a second.
This is what we call little g. It's that constant pull we feel every single day. And here's a wild thought. Gravity actually gets weaker whether you go up or down from the surface.
Simple. You just have to go really, really fast. A very specific speed, in fact.
Basically, you have to give an object enough kinetic energy, enough speed, to overcome gravity's pull. For Earth, that magic number is 11.2 kilometers per second. That's our escape speed. But even if you don't hit escape speed, you can still get into orbit. Satellites are basically just falling forever. We figured out so much, but gravity is still the architect of the cosmos. So, what mysteries does it still hold?